Today we are going to learn how to solve linear inequalities. So these are just like equations, but instead of saying two sides are equal, we are going to compare them. So an inequality tells us that one side is greater than, less than, or equal to the other side, but not always equal. So let's start with understanding the symbols that we use in linear inequalities. So the first symbol is less than symbol. The other one is greater than. So let me give an example for each of them. For the less than, so we can say that x less than 5. So it means that the values which is less than 5, it could be 4, 3, 3.5, whatever, but it's not 5, it's not equal to 5. For the greater than, we can say that x greater than 2. So any value greater than 2, it could be 2.1, 3, 5, 7. So the next symbol is less than or equal. Less than or equal. Example, x less than or equal 4. In this case, x could be equal to 4, and also it should be less than 4 at the same time. Or, so it could be 3, 3.5, 2. And the last symbol that we will see, greater than or equal sign. Greater than or equal. So for example, x greater than or equal to 1. So x could be 1 or could be greater than 1, 2, 3, 3.5. So think of these like signs showing a range of possible values. So let's start with solving the one-step inequalities. Let's say I have an inequality such as x plus 3 less than 7. So just like solving equations, we are gonna keeping the inequality sign. The main idea, as in equations, we are gonna find an expression for just x. So we are going to eliminate all the terms other than x. It's very similar to what we did in equations. So we have plus 3 here. In order to eliminate that, we are going to subtract 3 from both sides. So after that, what I have on the left side, x plus 3 minus 3. So plus 3 minus 3 are gone. I have x. I will put the sign less than 7 minus 3, which is 4. So that's the answer. X less than 4. Another example, x minus 5 greater or equal than 2. Again, I'm going to isolate any terms other than x. So I have minus 5 here. So I will apply the inverse operation, which is adding 5 to both sides. So if you look at the left side, I have minus 5 plus 5. They are cancelled out. I have only x greater or equal 2 plus 5, which is 7. So that's the answer. X greater than or equal 7. So there's a very important rule. Let me call it key rule in inequalities. So that's very important. So if you multiply or divide both sides of an inequality by a negative number, you must reverse the inequality sign. Let's work on an example to understand that. Let's say I have negative 2x greater than 6. So in order to get an expression related to just x, I need to get rid of negative 2. It's in multiplication form, negative 2 times x. So I will apply the inverse, which is division. So I will divide both sides by negative 2. So if you look at the left side, negative 2's are gone. I have only x. But since I divide by negative number, I must reverse the sign. It's normally greater than. I will make it less than. Why is that? Because I also divide the right side by negative 2. So it was normally 3. If I divide 6 by 2, it will be 3. But in this case, it will be negative 3. So I should reverse the sign. So the answer is x is less than negative 3. So let's say I have negative 3x less than or equal to 9. So what I need to do, I need to divide both sides by negative 3. So on the left side, negative 3's are gone. I have x. I will reverse the sign. I will make it greater than or equal 9 divided by negative 3, which is negative 3. So the answer is x greater than or equal negative 3. So let's do some examples on two-step inequalities. So I have 2x plus 3 greater than 11. So the same procedure will be valid here that I used in equations. So I will get rid of plus 3 first. So minus 3, minus 3. So left side I have only 2x because plus 3 and negative 3 are gone. Greater than, on the right side, 11 minus 3, which is 8. So the next step will be dividing both sides by 2. So 2's are gone. On the left side I have only x greater than 8 divided by 2, 4. So x greater than 4. Another example. Let's say I have x over 3 less than or equal 6. So here I divide x by 3. So the inverse of division will be multiplication. So I need to multiply both sides by 3. So on the left side, 3's are gone. I have only x less than or equal. On the right side, I have 6 times 3, which is 18. X less than or equal 18. Another example. X over 2 plus 1 less than or equal 5. So let me start eliminating plus 1. So subtract 1 from both sides. On the left side I have x over 2. 1's are gone. Less than or equal. On the right side 5 minus 1, which is 4. So as the second step, since I have division here, I will apply the inverse of division, which is multiplication. So I will multiply both sides by 2. On the right side, 2's are gone. I have x less than or equal 4 times 2, 8. So the final answer, x less than or equal 8. So let's do some more complex examples. 5 minus 2 in parentheses x minus 3 greater than 1. So according to PEMDAS, the first operation will be solving the parentheses. So I will distribute 2 into the parentheses, 2 times x, 2 times negative 3. So let me write the expression again. 5 minus 2x, negative 2 times x, negative 2x, negative 2 times negative 3. So negative times negative will be positive. So plus 6 greater than 1. So let's combine the like terms. I have minus 2x here, negative 2x, 5 plus 6 plus 11 greater than 1. So let's get rid of plus 11. I will subtract 11 from both sides. On the left side I have plus 11 minus 11, they are gone. I have only negative 2x greater than, on the right side, 1 minus 11, which gives me negative 10. So the next step will be dividing both sides by negative 2. So negative 2's on the left side are gone. So let me continue from here. I have only x. Since I divide by a negative number, I will reverse the sign. It's normally greater than. I will make it less than. And negative 10 divided by negative 2, which is positive 5. So the final answer, x less than 5. Another example, 1 over 2x minus 3 over 4 greater than or equal 1 over 4. So the first step will be adding 3 over 4 to both sides. So on the left side, negative 3 over 4, positive 3 over 4, they are gone. I have only 1 over 2x greater than or equal 1 over 4 plus 3 over 4. 1 over 4 plus 3 over 4. If you look at the right side, I have the same denominators, so I can add them. So 1 over 2x greater than or equal 1 plus 3, 4, 4 over 4, which is 1. Let me continue from here. So I can write the expression as 1 over 2x greater than or equal 1, since 4 over 4 is 1. The next step will be multiplying both sides by 2 to get rid of 2 in the 1 over 2. Let me separate this part. So the left side 2's are gone. I have only x greater than or equal 1 times 2, 2. So the final answer, x greater than or equal 2. Let's do another example. 2x minus 1 divided by 3 plus x over 2 greater than 4. So let's combine the like terms first. Let's do the fraction work. So one of the denominator is 3, the other one is 2. So the first thing that I need to do is to make them equal to each other. So let's multiply the first fraction with 2 and the second fraction with 3. That way the denominators will be 6. So the expression becomes 2 times 2x minus 1 plus 3 times, let me write it with another color so that you can track easily, divided by 2 times 3 is 6 greater than 4. So I will focus on the parentheses on the numerator. So 2 times 2x, 2 times negative 1. So 2 times 2x is 4x, 2 times negative 1, negative 2, and the second parenthesis will be 3 times x, so which is going to be 3x plus 3x divided by 6 greater than 4. So let's combine the like terms. Let me separate this part. So I will continue from here. So 4x plus 3x, 7x minus 2 over 6 greater than 4. So I need to get rid of 6. So what I can do, I can multiply both sides by 6 times. So if I do that, on the left side 6 are gone. I have only 7x minus 2 greater than, on the right side I have 24. Then the next step will be adding 2 to both sides to get rid of negative 2. So that makes the left side 7x because negative 2 plus 2 are gone, greater than, on the right side I have 24 plus 2, 26. And the last step will be dividing both sides by 7 to get rid of 7. So 7's are gone. On the left side I have only x greater than, on the right side I have 26 over 7. So the final answer will be x greater than 26 over 7.